Electrical information is crucial for safe and effective work. A thorough review of any electrical information is paramount. This involves carefully examining all aspects of the provided details, including diagrams, specifications, and instructions. Pay close attention to voltage levels, current ratings, and wiring configurations. Understanding the specific requirements of the electrical system is essential. Always verify the accuracy of the information with reliable sources, such as manufacturer's documentation or relevant industry standards. After reviewing the initial information, it's important to formulate any follow-up questions. These questions should address any areas of uncertainty or ambiguity. Clearly articulate your questions to ensure you receive comprehensive and accurate answers. Seek clarification on any technical terms or concepts that are unfamiliar. When posing questions, provide specific context to help the responder understand your concerns. For example, if you're unsure about the grounding requirements for a particular piece of equipment, explain the equipment type and its intended application. It's also helpful to reference the specific section of the documentation that raises your question. During the review process, consider the potential implications of the electrical work. Evaluate the impact on the overall electrical system and ensure compliance with all applicable codes and regulations. The National Electrical Code, or NEC, provides comprehensive guidelines for safe electrical installations. Familiarize yourself with the relevant NEC articles and tables. For instance, NEC Table 310.15b16 provides ampacity ratings for various conductor types and sizes. Understanding these ratings is crucial for selecting the appropriate conductors for a given application. When calculating conductor ampacity, consider factors such as ambient temperature and the number of current-carrying conductors in a raceway. These factors can affect the conductor's ability to dissipate heat and may require ampacity adjustments. Remember that electrical work can be dangerous if not performed correctly. Always prioritize safety and take appropriate precautions. Wear personal protective equipment, such as insulated gloves and safety glasses. De-energize circuits before working on them and verify the absence of voltage with a reliable voltage tester. If you're not comfortable performing electrical work yourself, it's best to hire a qualified electrician. A licensed electrician has the training and the experience to perform electrical work safely and in compliance with all applicable codes. Effective communication is key to successful electrical work. When communicating with others, use clear and concise language. Avoid jargon or technical terms that may not be understood by everyone involved. Provide detailed explanations and supporting documentation when necessary. It's also important to listen carefully to the feedback and concerns of others. Collaboration and teamwork can help prevent errors and ensure a safe and successful outcome. In addition to technical knowledge, problem-solving skills are essential for electrical work. When troubleshooting electrical problems, use a systematic approach. Start by gathering information about the problem, such as the symptoms and the conditions under which it occurs. Then, use your knowledge of electrical principles to develop a hypothesis about the cause of the problem. Test your hypothesis by performing measurements and observations. If your hypothesis is incorrect, revise it and try again. By using a systematic approach, you can efficiently identify and resolve electrical problems. The electrical field is constantly evolving with new technologies and advancements. Stay up to date by reading industry publications, attending training courses, and networking with other professionals. Continuous learning is essential for maintaining your skills and knowledge. Furthermore, it is important to understand the specific voltage requirements of different types of equipment. Many residential appliances operate at 120 volts, while larger appliances such as electric stoves and dryers may require 240 volts. In commercial and industrial settings, three-phase power systems are commonly used, with voltages such as 208 volts, 277 volts, and 480 volts. It's crucial to ensure that the voltage supply matches the equipment's requirements to prevent damage or malfunction. Understanding grounding and bonding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Bonding connects metallic parts of an electrical system to create a low impedance path for fault current. Proper grounding and bonding are essential for minimizing the risk of electrical hazards. Always consult the NEC for specific requirements related to grounding and bonding. Another important aspect is the selection and installation of overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to protect electrical circuits from overload and short circuits. The size of the overcurrent protection device must be carefully selected based on the ampacity of the conductors and the load requirements of the circuit. Installing an undersized overcurrent protection device can result in nuisance tripping, while installing an oversized device can create a fire hazard. Always follow the manufacturer's instructions and the NEC guidelines when selecting and installing overcurrent protection devices. When working with electrical panels, it's important to maintain a safe working distance. This distance, known as the arc flash boundary, is the distance at which a person could be exposed to a dangerous arc flash. The arc flash boundary depends on the voltage level and the available fault current. Always wear appropriate personal protective equipment, such as arc-rated clothing and face shields, when working within the arc flash boundary. Before opening an electrical panel, always de-energize the circuit if possible. If de-energizing is not possible, use extreme caution and follow all safety procedures. Never work on energized electrical equipment unless you are properly trained and authorized to do so. When installing wiring, it's important to use the correct type and size of conductors. The type of conductor must be suitable for the application and the environment. For example, conductors installed in wet locations must be moisture resistant. The size of the conductor must be large enough to carry the required current without overheating. Always consult the NEC for specific requirements related to conductor selection and installation. Conduit is used to protect electrical wiring from physical damage and environmental factors. There are various types of conduit, including rigid metal conduit, electrical metallic tubing, and flexible metal conduit. The type of conduit used must be suitable for the application and the environment. For example, rigid metal conduit is typically used in areas where there is a risk of physical damage, while flexible metal conduit is used in areas where flexibility is required. Always follow the NEC guidelines when installing conduit. Electrical boxes are used to enclose electrical connections and protect them from damage. There are various types of electrical boxes, including metal boxes and non-metallic boxes. The type of electrical box used must be suitable for the application and the environment. Always follow the NEC guidelines when installing electrical boxes. Wiring devices, such as switches and receptacles, are used to control and connect electrical circuits. There are various types of wiring devices, each with its own specific function and application. Always use wiring devices that are listed by a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association. Always follow the manufacturer's instructions when installing wiring devices. When making electrical connections, it's important to use the correct type of connectors. There are various types of connectors, including wire nuts, terminal blocks, and crimp connectors. The type of connector used must be suitable for the application and the size of the conductors. Always make sure that the connections are tight and secure to prevent loose connections and overheating. Always follow the manufacturer's instructions when making electrical connections. The electrical drawings and diagrams are essential tools for understanding and troubleshooting electrical systems. These drawings provide a visual representation of the electrical circuits and components. Familiarize yourself with the symbols and conventions used in electrical drawings. Use electrical drawings to trace circuits, identify components, and troubleshoot problems. Always keep electrical drawings up to date and accurate. When working on complex electrical systems, it's often helpful to use a multimeter. A multimeter is a versatile instrument that can measure voltage, current, resistance, and other electrical parameters. Use a multimeter to troubleshoot electrical problems, verify circuit continuity, and check voltage levels. Always follow the manufacturer's instructions when using a multimeter. Understanding the principles of electrical safety is paramount. Electricity can be dangerous if not handled properly. Always take precautions to protect yourself and others from electrical hazards. Follow all safety procedures and use appropriate personal protective equipment. If you are not comfortable performing electrical work yourself, it's best to hire a qualified electrician. Regular maintenance and inspection of electrical systems are essential for ensuring safety and reliability. Inspect electrical equipment for signs of damage or wear. Test ground fault circuit interrupters, or GFCIs, regularly to ensure they are functioning properly. Replace any damaged or worn components promptly. Keep electrical panels and equipment clean and free of obstructions. By performing regular maintenance and inspections, you can prevent electrical problems and ensure the safe operation of your electrical system. When working with batteries, it's important to take precautions to prevent short circuits and explosions. Batteries contain corrosive chemicals that can cause burns. Always wear appropriate personal protective equipment, such as gloves and safety glasses, when handling batteries. Never short-circuit a battery by connecting the positive and negative terminals directly. Store batteries in a cool, dry place away from flammable materials. Dispose of used batteries properly in accordance with local regulations. Renewable energy systems, such as solar and wind power, are becoming increasingly popular. These systems generate electricity from renewable resources, reducing our reliance on fossil fuels. When working with renewable energy systems, it's important to understand the specific requirements and safety procedures. Always follow the manufacturer's instructions and the NEC guidelines when installing and maintaining renewable energy systems. Smart home technology is also becoming increasingly prevalent. These systems use electronic devices to control various aspects of the home, such as lighting, temperature, and security. When working with smart home technology, it's important to understand the electrical requirements and safety procedures. Always follow the manufacturer's instructions and the NEC guidelines when installing and maintaining smart home systems. The NEC is updated every 3 years to reflect changes in technology and best practices. Stay informed about the latest NEC requirements to ensure your electrical work is safe and compliant. Obtain a copy of the latest NEC and review it thoroughly. Attend training courses and seminars to learn about new NEC requirements. Consult with experienced electricians and electrical inspectors to clarify any questions you may have. By staying up to date on the latest NEC requirements, you can ensure your electrical work is safe, compliant, and up to industry standards. Electrical work should be a source of pride, knowing that you are contributing to the safety and efficiency of buildings and homes.